I like the argument of let's go a bit more slowly so that at least we go in the right direction. That speaks to me.
I'm very much of the opinion you fail fast and that failure is a good thing. You learn from failure. Failure stands for first attempt in learning. And I'm very much about those fast feedback loops.
The most frustrating bit about chaos engineering, at least from my days, was that it's fairly easy to get everybody on board to say that we should be doing that. They see the benefits very quickly. And then it's an entire conversation afterwards to actually prioritize that. Because that shiny new feature there is like something concrete, and improving the reliability from 85% to 90% doesn't feel as real to a lot of people.
If you're going for 100% availability, you leave yourself no room to be creative and innovative and push the envelope.
Hello and welcome. This is me again, Nico, and today I've got the pleasure to talk to Rob Charlwood. Rob is the CEO at Supercharged, and is that the right way of saying that? You've been around the block a little bit. And we're going to talk about a lot of stuff, including why your SRE is broken and what you're doing wrong about it. How are you doing today, Rob?
No, I'm well, thank you. Thanks very much for having me on. I'm a big fan of the show. Really enjoyed a couple of your most recent episodes. The episode you did with Colton Andrus on chaos engineering was fascinating. And the episode with Ravi Moda on the life-changing performance with the Wim Hof method. Also really interesting. I actually use a lot of the Wim Hof method myself.
Wow, okay. A fellow Wim Hof method fan and chaos engineering fan. Wow, we've got more in common than I expected. And just to give you an idea how kind Rob is, last time we were trying to record this, my kid, who is currently 8 months old, just needed some attention. And we tried to record it with him, but he just wouldn't have it. So this is attempt 2. Thank you for coming and doing this.
Thank you.
Rob, what is Supercharged and what does it have to do with the Dodge Charger?
So it doesn't have anything to do with the Dodge Charger. Supercharged, primarily we're an engineering consultancy, but we're very much specifically focused in a fractional basis, working as a fractional CTO, working as fractional engineering in various different disciplines: software engineering, site reliability engineering, platform engineering, platform security. We come in and we can offer very tailored, very specific consultancy, but on a fractional basis. You're not having to hire an engineer for a 6-month stint or a 9-month stint. You can have an engineer assigned to your account or to your project for X number of days a week or X number of days a month, and you just pay a monthly retainer and you have that dedicated engineering resource at hand. Focusing more at the moment on the strategic level stuff, so very much fractional CTO, fractional head of engineering, fractional VP of engineering, so working with small to medium-sized startups to help them grow their businesses, grow their engineering teams, and build a really positive engineering culture within those teams.
And you're doing all of that, and you're also working at John Lewis. Is that correct?
That's correct, yeah.
How are you pulling that off?
So the foray into fractional is still fairly new. We've only got a couple of fractional clients at the moment. And by taking a fixed period consultancy work with John Lewis, I'm able to work, pay the bills, whilst I grow out those other aspects of the business. And the nice thing about John Lewis is that it's a very challenging role. And again, it's strategic level. So I've been brought in as an architect to help them move their on-premise services, infrastructure, functionality from their 2 physical data centers and get into public cloud. They're on quite tight timescales for that. They want to be out of the data centers within a certain period of time. And so I've been brought in to help them do that, but looking specifically at helping them from a cloud networking, cloud architecture perspective. So it allows me to focus on some new skills and helping really large organization to solve a very difficult problem, which is obviously applicable to a lot of different types of work that might come our way.
It's a little bit of a polarizing one, the kind of leadership, fractional CEO, CTO, head of engineering role, because I don't know if it's just my echo chamber, but for some reason I keep seeing that on LinkedIn, people arguing, and there's basically 2 camps. There is the camp that says it's just as like any other role, you can do it. You probably don't need full-time CTO if you're a small startup anyway. And then there's the other camp that basically says this is a pile of horse shit. You can't do that properly if you're not fully committed. This is not shift kind of work. I'm assuming you might be biased here, but I'm going to ask you anyway. How does it work? Like with the commitments and being fractional, what kind of fractions typically do you work with? How do you make it work?
It's a great question. And both camps do have valid arguments to certain degrees. As with everything, it's balance. I think there probably are some companies or some consultancies out there that offer fractional CTOs that are potentially just blanket filling positions within companies, and those companies, especially small startups, they're not getting value for money because the consultants that are being provided are very much, it's blanket. I'm very much targeted at working with a few very select clients within certain spaces. So I focus in the startup world. That's the world that I find most interesting. It's also the world where I can add the most value as well. So at the minute, I'm working with two very small startups, one of who I've been working with for about the last 8 years on and off. I was working for them fractionally at the same time as a full-time job, and they're still with me 8 years later. And the other one is fairly recent, within the last 2 or 3 months. And so I'm working with them, but I'm giving them all the time and the energy that their projects deserve. And that's why I only take on a select number of these particular projects. And I only work with startups where I'm really engaged and I believe in the product that they're building. So it's all about, for me, it's all about giving the customer value for money and giving them the expertise that they need and actually helping them to grow their business in a meaningful way. One of the things, it's actually a friend mentioned this to me a couple of years ago, it wasn't even a couple of years ago, last year I think it was. He's also a fractional CTO, and he said that one of the biggest misconceptions that companies have when they come to you as a fractional CTO is that you're going to come in and suddenly everything is going to speed up. And what he actually said to me was that when you're going in there, you're telling that client that to a degree they're paying you to slow them down, to make sure that the foundations are built right, so that the correct things are in place, so that when the company does scale, those fundamentals are in place. It's, as with all things CTO, especially in startup world, it's very much striking a balance between stability and getting a product to market, proving that product fit, and hitting those deadlines for any potential investors. So it's a very fine line between slowing them down and making sure that they have all the core fundamentals in place so that they can grow successfully, but also ensuring that they move quick enough and iterate quick enough that they can prove product, they can find investment, and they can grow their engineering team and their engineering culture effectively. It's a fine balance, but it's a role that I really enjoy because it's quite challenging in that you're taking input from lots of different places. You've got the requirements and the needs of the CEO and the rest of the C-suite board who are looking to obtain that investment. You're also listening to the engineers and the engineering team. You're working with your project managers or your delivery leads and finding out where the things that they're butting up against and trying to streamline those processes and meld things together in such a way that the company can then grow. It's just a really interesting job. And it's something that I want to do more and more of. Hence why I'm focusing more of my time on that now.
I like the argument of let's go a bit more slowly so that at least we go in the right direction. That speaks to me. What I'm wondering about is like, how do you pull it off time-wise? If you do your normal working hours for John Lewis, do you work evenings or do you work like with US-based clients so that you have the time zone advantage? How does that work?
So one of my clients is US-based. The other is UK-based. And they're, due to where that they are in their journey, with them, I'm able to work evenings and weekends. And if there's if they've got pitches for investment companies or they've got meetings with important investors where they're trying to attract funding or they need somebody there that is able to provide that expertise at more of a C-suite director level, then I will work with them during the week. During weekdays, I will let John Lewis know that I'm unavailable for the day or unavailable for these 2 days, and I will go and work directly with that client. I'll attend their meetings, I'll meet their investors and provide whatever input I need to make sure that meeting is a success.
How is fractional CTO different from consultancy? It sounds much more grand, obviously, but is it just like a vocabulary thing?
In terms of the technical expertise that I'm offering, there's little to no difference. I would say I probably invest slightly more of my time into the fractional work because that's the work I find the most interesting. But in terms of the actual quality of the expertise and the knowledge that you're receiving, it's really not that different. But when you're a consultant or offering consultancy services, generally you might only be working for one client for 6 months or 12 months or 9 months or whatever it might be. Whereas with a fractional work, I might be working with 4 or 5 clients a month. And so I get that variety. And that's one of the things that appeals most to me about it. I like variety. I like working with lots of different startups on lots of different interesting types of technology and not being locked in to 9 months with this particular client or 6 months with this particular client. So for me, it's about variety and working on different interesting projects, multiple different interesting projects. It's just a slightly different way of working. So instead of a company having my dedicated time X number of days a week, or they pay me per day, it's more a case of you might have 3 or 4, maybe 5 select clients, and they basically pay you a monthly retainer, and that monthly retainer will cover a certain amount of engineering time dedicated purely to them. And if they need extra on top, then we can discuss that. But what it allows is it allows small scale startups that don't have huge amounts of money. I'm talking like startups that kind of pre-seed here, so they've not really made anything yet, but they need that guidance because a lot of the time CEOs aren't necessarily super tech savvy. I've been lucky in all the startups that I've worked at that the CEO has been very tech savvy, almost as tech savvy as the CTOs. But based on my experience in the real world or working more broadly, I've come to find that a lot of CEOs don't know how to build good engineering. They know the product really well, they know the service really well, and they know what the investors want really well, but they don't know how to get there in a quick, efficient, and scalable way that doesn't paint them down one path. Certainly with early stage startups, what I found is that you don't want to be making any decisions as a CTO that restricts that company's ability to be able to pivot. So in every startup I've worked at, when I've joined, they've been building a certain product or a certain service. And then within 6 months, 12 months, depending on the investors that they get on board, depending on where the market is going in that particular industry, that startup has had to pivot. And if the wrong decisions have been made early on and we've been too strict, or we've over-engineered or boiled the ocean when we didn't need to, then it slows down that pivot. And when you're working with a company that doesn't have very much money, you don't have time to waste. And so it's all about making those good decisions early on and then helping the company to grow from there and allowing them the space and freedom to pivot if they need to.
How did you end up doing this? Sounds like consultancy with multi-threading in it, basically.
Yes, I've been in engineering for about 20 years now. I started off, as most of us do, writing HTML web pages in my bedroom and moved into software engineering, back-end software engineering. I did that for about 10 years. And then from there, I got a real kind of interest in the underlying stuff, the infrastructure that upholds all of this stuff. So I spent a lot of time in platform engineering, building the underlying infrastructure. And then I was like, this is really cool. How do I make sure that this is all resilient and reliable? And how do I monitor and track all of this? And how do I actually ensure that this stuff is resilient and reliable? And that led me down site reliability engineering, which is where the bulk of my stuff had been for the last couple of years. But every role over the last couple of years, I found that I was working at more and more of a strategic level. And so I was getting that top-down bird's eye view of things, but I was actually able to make meaningful changes and help the companies make meaningful choices that actually improved their engineering culture. It improved their response times to incidents. It improved the resiliency and reliability of their platforms. And I found that I really enjoyed that sort of work. And so when I started Supercharged, that was the direction that I decided I wanted to go in. And I knew that the fixed term consultancy stuff would play a role for a time, but in the long term, I want to work with a few select clients in purely fractional basis.
There you go. So the first lesson here is when you start doing reliability and chaos engineering and all of that, you're inevitably going to end up in the C-suite. So there you go.
I guess you don't have to. I guess it really depends on where your interests lie. So for a long time, I was very much head in the weeds in implementation detail. And I loved all of that. I found it so interesting and fascinating, especially when I got into the chaos engineering. I loved the learnings that you could find from thinking creatively about how things could go wrong, and the flexibility and ingenuity that some of the open source chaos engineering libraries allows you to come up with. I went down a bit of a rabbit hole with it, and I found that I really enjoyed it. And everywhere that I worked, that I was able to implement this and push this forward, they saw just dramatic changes in not only the reliability of their services and the resiliency of their services, but actually their engineering culture and the way that their engineers thought. So I'm very much of the opinion you fail fast, and that failure is a good thing. You learn from failure. What is it they say about fail? Fail stands for first attempt in learning. And I'm very much about those fast feedback loops. I want to know quickly, and so I like to iterate quickly. And chaos engineering allows you to do that. But when you bring in that acceptance that failure is inevitable into the engineering teams, and people accept that, as you find that people actually change their engineering practices and the way that they think, like from day dot. So as soon as they start designing a service, they're thinking, how could this go wrong? What are the scenarios here where this service might stop functioning? If we're coupling this service to that service, what happens if that service goes wrong? Are we tightly coupling these services together? Can we update one service without also having to update the other service? And so you're thinking about those things from like a much, much earlier set point. You're doing things like failure mode effects analysis. And from that, you can tease out, like just by doing that, you tease out your initial chaos engineering scenarios and the things that you want to check. And you're actually building that into your pipelines as you go. And you're just building your software with like a completely different point of view as your starting point. And what we've found from that is that, like I say, the services are more reliable and resilient because they're getting that stress testing. They're actually being tested in ways that we wouldn't necessarily think to test them. But also the engineers are starting to think like that. And they're looking for ways where they can actively introduce uncertainty, potential incidents into a system to see how it behaves and how it responds. And I think a lot of the engineers do actually find it quite interesting. And you can see their code change, that their code changes to be more defensive. They're thinking about retries. They're thinking about fuzzy back off, and they're thinking about graceful degradation as a starting point. And as far as I'm concerned, that can only be a good thing.
You're preaching to the choir a little bit here. But yeah, I'm glad a lot of people who got into the chaos engineering route follow the same path, myself included in that. They started off as regular engineers building code, and then got a little bit bored and interested in what happens underneath, and started unwrapping the onion and ended up reading the kernel code and trying to understand how this actually works. And I'm very happy to meet a fellow practitioner here. Awesome. What practical advice can you give to anybody who just heard you speak and is thinking, okay, that's all great, but I'm destined to do more than writing code too. I've done my decade of doing this. I can't look at it anymore. I want to do higher level stuff. How do people transition from that?
It's a really good question. So the way that I naturally traversed into this was I understood that in the weeds and in the detail stuff very well. As I was working with the CTO and with the CEO in these various different startups, because I worked at a couple of different startups full time before I started my own consultancy. And obviously, because I was the kind of the expert in those areas, I was pulled into various meetings, various strategic design decisions or planning sessions where they were thinking about how do we go about this next step. And I was able to contribute something to those meetings. And gradually, as I contributed more and more, and what generally would happen with, certainly in a startup, I would be called in, I would help them with these decisions or with these designs, and then I would go away and implement them. And so what I learned from that is I got that feedback loop. Okay, we tried that, it didn't work. Okay, let's try this. And I've been very fortunate, both the startups that I've worked at, they've very much bought into we need to fail fast. They were very much advocates of proof of concepts, test and learn. Here's 2 days, go away, let's try this, let's see if it works. Let's see if we can make this scale to our needs or whatever it might be. And we were allowed to fail at these things. If they didn't work, we could come back and tell the CTO or the CEO, that, okay, it doesn't work for XYZ reason, but we'd also come back to them with an alternative. Because we'd have thought about that as we were finding this stuff out. We were thinking, well, how could this work? What would be a viable solution here? And so it wasn't just a case of going back to them and saying, no, we can't do this for XYZ. Generally, we always had another idea or some way that we could simplify the design or strip it back slightly so that it still met the technical requirements, but wasn't going to take as much time, or it removed one of the technical blockers that we might have had. And so by going through that kind of constant cycle of working on the designs, working on the planning from a more strategic level to actually doing the implementation, you learn a lot from that process. And then gradually you just find yourself more and more in those strategic conversations and those design meetings and those design authorities and the security audits, and less in, okay, we need Rob to go away and implement this.
What would you do if you weren't allowed to fail, other than finding a new job?
If you're not allowed to fail, that's a really good question. I think ultimately, if you're working for a company that are like that or a startup that are like that, then you need to work with the leadership, the senior management, whoever it might be, to help them to shift the mindset. So thinking about basically selling them modern engineering practices, selling them DevOps working processes, shared accountability, shared responsibility, shared ownership of everything, and getting rid of those knowledge silos and promoting the idea that in order to move quick, you need to fail quick. Certainly in startup world, you need to be able to do that quickly because you're working on a runway, you've got limited budget available, and you need to be able to move fast. And so I think this is a problem that I've encountered a few times at larger organizations as well, is that you need to get that leadership buy-in, because what the leadership filter down is the culture that is set. And so if the leadership are filtering down that failure is not acceptable and that fingers are pointed and blame is assigned, not only is that a really kind of toxic environment to work in, it's also very unproductive. You're not going to move anywhere very quickly. I'm very big on psychological safety. So all of the engineering teams that I've helped to build is very much geared around psychological safety. So engineers feeling comfortable to raise concerns, engineers feeling comfortable to make mistakes, engineers feeling comfortable to fail with a proof of concept, and to be able to come back and share those findings, not just within the team, but sometimes in a larger organization across multiple teams, because in large organizations, quite often, multiple teams have the same problem and they're both doing the same sort of work and they're duplicating and wasting time and resources. So simply by sharing, okay, we tried this but didn't work, you might save another team 30 hours work because you've tried it and it's failed, but you've learned something from it. So very pro building engineering teams, that psychological safety is there, but that culture is built from the top down. So having your leadership, having a very clear plan of this is the pathway, this is the North Star, this is what we're working towards. We don't mind how you get there. These are our deadlines. Certainly as a startup, you quite often have deadlines for VCs or investors or people that are considering investing. They want to see demos at certain times. That's fine. You can have those deadlines in there. But then you work with your engineers and you work with the stakeholders and you work with the directors and the board to work out, okay, where can we move quickly and meet these deadlines, but without sacrificing resiliency and reliability? Because one of my favorite questions to ask people is, certainly within startups, one of the first questions I ask them is, what's your most important feature? And all of them will come out with some wonderful answer about a particular aspect of their software that does something that no other software on the earth can do. That's great. But actually your number one feature is reliability. If you can't access the service or the functionality, it's useless. And so building on that and helping them to understand that starting with a solid base and thinking about failure from the start, building in those things from the start. Yes, the software engineering might take you a little bit longer. You might have to invest a little bit more time and money into chaos engineering. Even if you're not willing to spend money on a dedicated chaos engineering solution or spend a whole lot of time working with open source software, if you're a very small project or a very small startup, you can do it with Python scripts, Bash scripts. You can do this stuff quite simply and get value from it. And so that allows you to build on something relatively solid. You've got a starting point, and that allows you to iterate quicker, fail quicker. And people aren't worried. If stuff fails in production, people aren't worried because it's being pushed to production 10, 15, 20 times a day. And you're only ever pushing out tiny atomic incremental changes at that point, because as you're probably aware, pushing out big, humongous change sets is inevitably a disaster. So pushing out those small atomic changes 10, 15, 20 times a day and having those modern engineering practices that allow you to do canary deployments or allow you to roll back very quickly, very seamlessly, means that it takes away a lot of the fear of running this sort of stuff in production to real customers, because you know that you can fail back quickly. You know that you can fail forward quickly. If there's a quick patch you can apply to it to fix it, you can get it out the door quickly. But you can only do that if you're failing quickly, because you need to be able to iterate.
Jesus, you just triggered my PTSD with some big bang deployments. Do you find yourself thinking, I sound a little bit like a primary school teacher, telling people to sit straight and telling them how that's going to pay off in the future? And they won't listen?
Sometimes, yes.
Or do they pay you enough that they listen?
Broadly speaking, I think if you're open with the trade-offs of modern engineering practices, because there are sometimes you do have to invest a bit more time or a bit more effort up front, or you might have to risk, if your product that you want to demo to an investor is failing 50% of the time, but your investor wants to see X new feature by this date, is it going to be more important that investor has that feature or that they can access it 99.9% of the time? Because there's no point in having that feature if every other click it's failing, because that looks really bad and people aren't going to want to invest in that. And that there are trade-offs to it for sure. But as I was saying originally, it's balancing speed of iteration and speed of development and adding those new features and adding value to the customer, but whilst also ensuring that we're doing so in a sensible way where the service is actually stable.
I think the most frustrating bit about chaos engineering, at least from my days, was that it's fairly easy to get everybody on board to say that we should be doing that. They see the benefits very quickly. And then it's an entire conversation afterwards to actually prioritize that. Because that shiny new feature there is like something concrete, and improving the reliability from 85% to 90% doesn't feel as real to a lot of people. Do you have golden nuggets of wisdom of how to deal with that?
It's a really great question, and I've encountered the exact same sort of thing, especially in large organizations. They really like the idea of what it is that you want to do, but actually getting that implemented and getting value from it, and also the amount of value that you get from it as well, varies from organization to organization. For example, I helped a big bank get some chaos engineering in, but what we found is that they could only get certain value from it because they're a bank, super secure, they've got to be compliant for the regulators, and they get fined if certain things happen. Banks are obviously very risk averse, and they would place limitations or like ring fence the chaos, which still has value, but they're not getting the same sort of value as maybe a startup would, who have just fully embraced it and gone with it and implemented it as part of, when they initially set up their CI/CD pipeline, they do their first round of chaos engineering then. They implement it from day dot, and it's just part of their development process. So I've definitely seen the same sorts of things, and especially in large organizations where teams tend to be siloed or fractured, and you need the collaboration of 10 or 15 different teams sometimes to get the relevant setup. So for example, if you're using something like Harness's chaos engineering module, which is part of their CI/CD tool, you need to install agents into your cluster. You need to install agents onto any virtual machine compute that you might want to have these sorts of things run on. And there's a whole bunch of security around that, certainly on the Kubernetes clusters, because these agents need certain levels of elevated permissions and access to be able to cause this chaos. And so you're getting sign-off from the security team, you're getting relevant connectivity in from networks, you'd have to work with the cloud platform team to get the stuff installed into the cluster, you'd have to work with the DevOps team to make sure that the images that the cluster is pulling for the agents have all been vetted by security and have gone through relevant checks. And so actually getting this stuff into place sometime is the biggest challenge. But once it's there, you can then iterate fairly quickly. So we picked a couple of large projects. They were moving from on-prem into the cloud. So it gave us enough scope because they were big projects. They had the clout to be able to say, we need to be able to do this. But once we got to a point where that functionality was there, then they could then start iterating with those service teams, with the engineers working on those service teams to actually start getting those tests in and running. And we did a couple of hack days with this bank's infrastructure, and engineers found stuff just in the hack days on the services that they were building that was broken, just like outright broken, that would never have been picked up had they just gone all the way to production with this. So even from a hack day, you can gain massive value from chaos engineering. It doesn't have to be all-encompassing. You don't have to run it in production like Netflix do. That's all going to depend on your maturity level and your appetite for risk and your ability to be able to aggregate and separate production chaos from actual real production incidents and alerting on the right things. So you need a certain level of maturity to be able to go there. And obviously Netflix have built that in from the ground up. And that's not to say that other companies can't do that. They absolutely can. But I think you need a certain level of maturity there for that to really work successfully.
And that neatly brings us to the big question. So Rob, why is my SRE broken?
It can be a kind of a manner of reasons. Ones that I've encountered the most is, we touched on it before, but engineering culture is a big part of it. So having that psychological safety, engineers being able to raise concerns, engineers being able to be proactive, engineers having enough and access to be enabled to actually go off and just do things and get the job done, whilst also being restrictive enough that they're not being granted root access to the system. You're still working to minimum required access levels for that particular role within the organization. So empowering engineers to have that freedom, I think, is a big one. And the psychological safety, being able to fail and learn from those failures and not have the blame game happening. If there's an incident, if there's a problem, fingers shouldn't be being pointed. All we do, we get in a room together, we work together, we do the root cause analysis, we find out what went wrong in a totally blameless way, and then we work with the relevant service team or whoever it might be to fix that incident so it doesn't reoccur again. So engineering culture is a big part. The other thing that I've seen quite a lot is SRE. I think one of the Google engineers said this, but class SRE implements DevOps. It is effectively an extension of DevOps with a whole bunch of extra useful ideas and thinking methodologies and ideas and functionality workflows on top of DevOps practices. If your DevOps is fundamentally broken, then quite often when you're trying to implement SRE, it doesn't work, or it works, it doesn't work very well. If you have loads of knowledge silos and teams don't want to work with each other and teams are small and very narrow in focus and teams don't have shared accountability and don't have shared responsibility, there's that whole chuck it over the wall, it's your problem game, or it works on my machine. That whole culture, it doesn't lend itself to site reliability engineering. We need everybody collaborating across the entire stack, across the entire life cycle of a product, whatever that might be. It could be, some people do it across projects, some people do it across products, some people do it across infrastructure or networks. It varies from organization to organization, but how you split your engineering teams up and how you have them working plays a big part in just how effective SRE can be, because for SRE to really work well, you need that shared responsibility. You need people talking to each other and collaborating, and you need to be working with the cloud infrastructure and all of the underlying configuration for that, all the way through to telemetry and alerting and chaos engineering if you're implementing that, all the way through to actually working directly with the service teams on their apps to make sure that they're also thinking about things from an app level perspective and making sure that their path from GitHub to production is as smooth as possible. And so one of the biggest problems I've seen is when the fundamental principles of DevOps aren't being adhered to properly, it makes SRE incredibly difficult to implement. And getting DevOps right is really to be able to do SRE. And then the final thing is leadership buy-in. So as we touched on before, in order for SRE to really work, we need to be operating under the assumption that things will fail. Even in a bank, things occasionally will fail. Won't always be the fault of anybody within the bank, or it might not be any service within the bank. It could be AWS or Google or Azure, whoever it might be. They could be having an outage. But they need to fundamentally accept that failure at some point, somewhere in the stack, is inevitable. And they need to be propagating that down through the company that, okay, we know 100% is not attainable. It's too expensive. The more nines of availability you add, you exponentially increase your development costs and your resource costs. But also, if you're going for 100% availability, you leave yourself no room to be creative and innovative and push the envelope. And so a lot of it is about getting that management, that upper management, that leadership buy-in, allow those engineers and those teams to work within that way that allows them to fail fast, that allows them to iterate more quickly, and changing the workflows and the policies or the guardrails or the escalation processes that some of these big organizations have in place to get things done. You need to help them to remove that red tape, empower the engineers to do their job, and trust the engineers. There's obviously a limit to that, certainly within banks. There's always the threat of insider bad actors, of course, but that's why we have things like privileged access management and role-based access control and minimum required permissions for a user. People should be empowered to do their job in as much extent as it is available for them to do. If you keep putting obstacles and blocks in people's way, not only is it incredibly frustrating for the people trying to do the work, but it's also incredibly slow, and it wastes countless hours and hundreds of thousands of pounds a year in large organizations. And so getting that buy-in from the top down, that permission to change the way that you work, to accept failure as inevitable, but to prepare for failure and to be resilient to that failure and to learn from that failure, is one of the biggest ways in which SRE can be implemented effectively. But you need that buy-in from the top down.
That's t-shirt material right there. Rob, how do people find you?
I'm available on LinkedIn. I'm also on Instagram. But best place to reach me is over LinkedIn or email. It's just rob@super-charge.io.
Instagram.
Old school.
Do you get clients from Instagram?
Not so much from Instagram. No, it is more LinkedIn. Or generally speaking, the majority of my clients have come from networking and word of mouth. Speaking at conferences, I actually got a couple of really good leads when I spoke at SRE Day of London a few months back in March.
Plug. Appreciate it.
Yeah, it was a great conference. That was my first year there, but I'll definitely be back next year.
Awesome. Rob, it was great to talk to you.
And you. Thank you for having me.
Thanks so much for coming.